So before I begin, for last week's workshop, the notebook is there along with the presentation slides, and then you have the YouTube video recorded. So any one of you can, whoever was not there last week, can go to this YouTube video and see like what we discussed in last week's uh, workshop. So basically, what we did last week is just an introduction to SQL and DuckDB. We looked at like what's a database is, what are primary keys, and how different tables are linked with each other. Then how do you interact with a database? So then we had SQL, and using the SQL commands we looked into last week, and DuckDB is like one such tool which we used last time to talk to our database. Yeah, and in today's agenda we have, so like I already provided you some recap. So today we're going to look at more functions and subqueries uh, from the same database as we discussed last time, the COVID-19 synthetic data database. And then we look at creating some tables and how can you insert data into the tables. And next we will look at how we can export data and put into CSV. And so that's the export part. And then importing, we'll see how can, let's say you have a bunch of CSVs, then how can you put like extract data from a CSVs and put into a DuckDB database. So before we move on to the tutorial, let's discuss subqueries and functions. So subqueries are like just queries, uh, but the special thing about these subqueries is that these are like nested subqueries where you have one query inside the other query. So first the inner query runs, and whatever the result it gets, then you have the syntax of outer query running on the output of the inner query, and when all of the code runs, then you get the final answer out of it. And functions are built in or user-defined operations in SQL. So let's say, like for example, you want to sum a column or take a min, max, or just want to count something given a filter. Or let's say you want to manipulate some strings. Let's say you want to concatenate two strings or break the string into two parts. Those are some string manipulation functions which are built in into DuckDB. And then we have date and time preprocessing. So let's say you want to see like the difference between like how many months are between 2 days, or how two dates, or how many days are between two dates. So that's where you can use functions. Okay. Yeah. So yeah, I have a list of questions here. So once we are done with the tutorial, you can read these questions and see if you are able to answer these. So let's say if you are preparing for some interviews, and so if you go over all these, I think you will have a good idea of like basic SQL that like for your interviews, or even just to check your knowledge if you have learned something out of it. Okay, so let's go back to our collab notebook. And like we have already discussed the agenda, and so once you run the first cell, you will gonna import DuckDB here. And since I've already downloaded the database, it's like just like sitting here, but we haven't connected to it yet. So once you have done with this second cell, just please let me know, then we can start. Okay, thanks. So since we have downloaded this data, which is like the same data we were using in last workshop, it's the synthetic COVID-19 patients data set, has about 100,000 samples of COVID-19 patients. So once again, we connected to the database using this duckdb.connect command where we mention our database. And right now we just say read only equal to 2 so that we don't accidentally edit anything into the database. So once we have a connection here using the duckdb.connect command, and just to know that, okay, before running anything, we just would like to explore this database more and see what tables are inside. So we run this con.sql, which gives us like, okay, these are the tables inside the database, which starts from since it's the medical database, it's more related to the medical terms like medications, immunizations, and procedures, supplies, etc. And yeah, next we would like to know what columns are there. Let's say we want to query patients database to, let's say, find some particular patients. So for that, so every command in for DuckDB has this syntax that you start with the connection, put a .SQL to tell the connection that, okay, you want to run a SQL query or a command here. And then your command, which is are very similar to this normal sequence command from MySQL, you put them into strings and just say describe patients. And once you run it, it will just describe it. Okay, these are all the columns present in your patients table. Similarly, for medications, we can do the same thing here. And again, for immunizations. So once we have like some idea about what are the different columns and what are the different attributes associated with each patient or each medication uh, in the tables, we can move forward. Yeah, and so the first, let's discuss what subqueries are. So like we discussed that subqueries are just like queries inside queries, and they allow us to perform operations that require multiple steps in single query. So ideally, like if you don't know subqueries, what would you would do is like you run a query, then save it, the result as a view, and then you run another query on that. But instead, what you can do it here is just run 2 or 3 queries into like one single command. So, and then there could be multiple types of subqueries, which is like single row subqueries, multi-row and correlated. And I've described here in the text. And let's start with our first example. So we will use these subqueries to find patients based on specific criteria. So let's say if you're interested in to answer this question, that find all patients who have been prescribed medication with a base cost higher than the average base cost of all medications. So what ideally would do is first find what's the base cost of the patient's medication, and then find out, okay, what's the average from medication. So the part I'm highlighting right now is your first query, and then you have the subquery which selects patient, and this in the output of these patients, and then you get the result out of it. So once I run it, yeah, so I get a list of patients, and these patients are those patients which have a prescribed medication with a base cost higher than the average base cost of all medications. Now looking at correlated subqueries, so we can do row-specific comparisons, and just like if you're comparing two rows or two set of patients or multiple set of patients, and then you want to have an aggregate result on it. So for example, you have this question, let's say if you're interested in that find patients whose healthcare expenses are higher than the average expenses in their county. So again, like the straight way is to just first you will define that, okay, what patients are there, what's what's their average expense, and then what's the average expense in their county, and have a join. But in a subquery example, you can just put everything together, join up as one query. So for example, here we have one query which says select county, and then the average expense in that county from that patient that you would like to group by using that county so that you get an average expense by county. So that's your first query here. And now you would like to use this data set to extract some patients and then do a filtering on those patients who have a higher average expense than the number in their county. So once you run it, yeah, you get a list of patients who belong to a specific county. And just to verify that you got the right result, what you can have is like all the healthcare expenses of one specific patient. And see, it's about like for the first patient, Tammy 740, it's about like one 1.1.5 million, but the average healthcare expense in the county was 793K. So this gives you like some idea that, okay, you have finally have like a list of patients where the healthcare expenses more than the average in their own county. And again, like just to say that you have counted the right average for the county. Let's say you have two patients, let's say Jim and Tammy, who both belong to Bristol County here. You get the same value for the average expense. So you have like, you can just like verify or validate your results. Like, okay, you have your query is working as expected. Now, for more examples of subquery is identifying patients who don't have a prescribed medicine with them in the dataset. So what you do is here you have all the patients for them, which so where not exist. So this command here means that find everything where there is no matching in the medication. And once you find a list of those, return their first and last names. So in this query, that this is our the first query, and then the outer query runs on the result of the inner query, and that's how you get uh, a list of patients who don't have any prescribed medicine with them. Yeah, and again, like initially we did county level filtering for all the patients who have healthcare expense more than the county average of their county. You can like do the similar thing as well on city level. So for example, you have the same. First, you take the average healthcare based on city, and then you run this extraction query, which runs on the result of the inner query. You find out that these are all the patients whose expenses more than the average of the city query. Mm, Again, another example is that once you would like to have do a mathematical function, let's say you want to find a correlation between healthcare expenses and coverage. So there's a CORR function available in SQL, which can tell you that, okay, if you extract all these features, let's say healthcare expenses and healthcare coverage for all the patients, what's the correlation coefficient between that? Ideally, would assume that, okay, coverage should have higher correlation with expense, but that's not the case here. Yeah. So before we move on to functions, please let me know if you have any questions. Okay, let's move on to functions in SQL. So functions are basically just like if you want to do any data manipulation once you get the data out of your query. And there are multiple types of functions. So we'll look at string functions, date time functions, and then advanced functions at the end. So we'll start with string functions first. And the first function we'll study is concat function. It's just like if you want to concat or join two strings together. So right now here, what I'm doing is that once I have the patient table, I'm getting the first name and last name and then joining them together with a space and now treating it as like one single column. So that's how it works is that it fetches the first and last column first from the patient's table, concats them together, and now projects it as a full name query here. So if I run this, like you can see, okay, there's like a one space here, and for this one patient, we have this full name, like a new attribute or new feature for them, and this feature contains their full name joined by a space. Okay, next is data length, which represents the length of the number. It's almost like you have the len function in Python or len function on Excel. It's just that it just finds out what's the length of the string available in the given column. So right now I am outputting the first name here and then the length of first name. So you can verify that, okay, this name, the length of these strings are actually same as what is shown in the length in bytes column here. Okay. Yeah, next is left. So it's again similar to the Python function. Let's say you want to like cut some part of a string out and then display it. Again, it's like you start with the feature or the column here and then define that how many characters you want. So right now I have uh, the number five here, which means that, okay, I just want five letters from the name of that patient, the first name of that patient. So what I write is select left and then first. So whatever goes into the feature or the first column, it just truncates it. So just gets rid of the remaining part, just takes care of the first five letters and shows it into a table. Yeah, next is lower and upper, and this is useful, let's say if you want to convert into any strings to lowercase or uppercase. So I have like a hybrid example here where we lowercase the first name and uppercase the last name from the patient's list. And once we output, the result we get is like this query put everything into uh, lowercase the first name and then uppercase the last name and given this as an output. Okay, next is L trim. Similarly, have an right trim as well. So removes leading spaces from a string. So once you have, let's say, some address, if there are some leading spaces here, like in the beginning of the address, it will just trim them out. Okay, next is replace. Uh, this is useful. Let's say you have a very long string, you want to concatenate it, oh, not shorten it, and then make the result in a more compact format. So what I'm doing is here is that for all the patients who have a street in their address, let's say for example, this first patient who matches the criteria is and their address is 813 Casper Street, and now I want to turn this 813 Casper Street to 813 Casper ST in the short form. So what would I do is find all those patients where the address has this street in their long address name. And once I have it, I'll replace that. For that column, I will replace the street string by an ST string and project it as a short address. And just to visualize that it worked correctly, I have the first name, last name, the long address and short address. And once I run it, it will just say, okay, the query is successful and we have converted the long string to a short form of that string. Yeah, similarly, we have right, like it's very similar to the left part or the left command we saw earlier. Yeah, so right is that if you want to, let's say, have last or the rightmost six or five or six characters. So what we will do is just put the feature name here, put how many characters we want from the last of that string, and just say right. And once it returns it, we'll see that, okay, so this whole name was this thing, the just into 644. And now we just have like what, six letters from the end part shown here. That's how you can extract. Okay, similarly, it's substring. So let's say, what we initially looked at the like left and right, but you can also do like from between as well. Let's say you just want from 2 to 4 or 2 to 3. So let's say if I change from 1 to 4 and run it, it will give me string from 2 to 4. And unlike Python, SQL is the index starts from 1 to, so now I have all the letters at index 2, 3, and 4. So for this guy, just into 644, I have, so excluding J, which is at the index number 1, I have 2, 3, 4. And so we have ACIN. Uh, yeah, start at index 1 and then how many we want. So that's how it works. That starting at index 2, index 1, we want 4. Next, like what we did is like started at index 2 and gave me next 4 at starting at index 2. So that's how it's outputting ACIN from Jacinto's name. Next is regex replace, where you can use regular expressions to strip numeric characters. So let's say you have this example where you want to clean up this first name and last name, get rid of these numbers and just convert it to how actual name looks. So what regex is doing is just goes to those two columns, find if there is a matching string in, and if there is something matching, it just strips it. So how the function works is like, okay, you go to this first column, find any number, replace it by like nothing, which means that just strip them out. Yeah, so once we run it, we see that, okay, for the first name, we had this go to regex replace first name and then find any number, replace it. Similarly, for last name, we had any number, replace it. And that's how we can get rid of all the numbers in the first name and last name. Yeah, moving on to date time functions. So right now, if I run this, since this shows in UTC, so if I run this, it will show, okay, what's the time in UTC? So it's around like 9:25 right now. Yeah. Similarly, if you want to calculate difference between two dates, you can use this date diff function. We report the initial starting date and the last date. And since this 2024 is a leap year, so we should find 366. Yeah. The next is date part, where you want to return an integer from your date. So now what you want to do is, given the birth date, you want to have an year of birth, or in other words, you want to extract the year from this date. So you can use have this, that since this is a variable character, so now you will use like a cast function which casts this birth date as a date. So now, so cast changes the data type from string to a date type, and since date part requires a date type argument, so we have a date type argument as an output of this cast function, and it also takes another input which says what part of the date we want to extract. Now, for in this example, we want to extract the year part. So date part will extract the year from this string casted as a date, and once we put it as a year of birth and we run it, we can actually separate this the, the the year part from the date. Yeah. Similarly, we have another example of cast, which converts the value of one data type to another. So right now, what I'm doing is that casting the healthcare expenses, since it's a double, since they are numbers. Now I am casting that healthcare expense as a string. Once I run this, yeah. So right now, like the value looks same, but so the data type has changed because we have used a cast function. So initially, for healthcare expenses, we had a double data type since it's a number. Once we have used the cast function to convert into string, uh, we have converted it into a string. So now the data type has changed to a variable character. Okay. Yeah, these are some like 2 or 3 advanced functions. So just to know that, okay, what version of DuckDB you're running. So you can just use like select version, and then it will show you, okay, you're just using 0.9.2 version of DuckDB again. And let's say, and next is case, which is used to do like a if else type of condition in the select queries in SQL. It's very similar to like how you do it in Python. Let's say you have two condition. If they are met, then you do something. If they are not met, then you just do the alternative. So right now I have is that for all the patients, if let's say the healthcare expense is more than 10,000, then I say, okay, they have a very high healthcare expense. And once they don't have, or if the condition is not met, then you can say they don't really have a high expense and put it as a low. And then you start here, end this if else case, and case this out as an expense category in this column. And once you run this, yeah, so instead of uh, saying that, okay, if it's low or high, so let's say if you want to verify it, you can just put like healthcare expenses here and run this. So now this is just to like verify that, okay, for Justin Chris, the healthcare expenses was around 8,000, which is less than 10,000. So your query has put it like it says low, and for other it just says high. So you can just now verify that you got the expected result. Yeah, coalesce is another a function which gives you a non-null value in the list of arguments. So for example, if there is like nan or not a number or not a value, or there's like some missing values, it will put NA instead of these missing values. So if I run this using death and date here, so right now, so initially there was no values for all these patients, so they had null, or there was no value. So right now what you can do is coalesce. Instead of null, you can say not available. And since now this table is filled with all the values, you can do filtering on this dead date to say whatever. Let's say you want to find all the patients who don't really have a dead date. So we can just do a filter on dead date here to get the list of patients who are still alive. Okay. Next is current user, and let's say you are like multiple users are working trying to extract data, put data into the database. So once you run this one, it will just say the user. So now it just says start DB. Okay, so till now we have discussed everything about querying databases and doing select operations and some filtering on it to get data, like some data out of it. But now we'll look at like how do you uh, create a database and put a table into it. How can you populate that table with any data you have? So to do that, we'll first make this use this duckdb.connect without any arguments and sites of what this command is doing that. So initially we looked at there was this my database file available where we are querying the data, but right now we are just making an in-memory database. It's not available as a file, it's just into the memory. So once we run it, we have this new DB, which is a connection to an in-memory database. And for this database, just for an example, we would like to have a make a small library catalog system. And so once I run it, yeah, so this command has created a schema of this table. So for this new DB, it created a table inside which starts with books, and book ID is the primary key, which is the unique key for all the elements inside that table. And there are attributes associated with entry, which are the title, author, and published year, and two of them. The title and the author are strings like variable characters, and the published year is an integer here, which would be casted as a double inside the table. So once we have run it, just to check that if there is a table inside this database, we use this again show tables command for this new DB. And once we run, we get okay, there is indeed a table inside this database. And right now we would like to see if 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 the attributes we pushed in for this table, like the schema we defined, is actually there. So to describe this table, we find that okay, it has 4 columns where the book ID is an integer, and you can see it has labeled the key as primary here, like we defined in the command that label the book ID integer key as primary, and don't do and just and for the other attributes or other columns, just define the data type. So once we describe the table, we have the book ID as primary key and title, author, and published year as different columns for the table. And after that, now you have an empty table. So we can use an alter table statement to add a new column. So let's say you want to add a genre column for your table. So what you can use is this query which alters the table books, and the command is add column, which introduces this genre column. And the data type you want to have in this genre column is variable character. Let's say you, for example, like fantasy novels or like something like Harry Potter or like we have a lot of examples here. So let's say you have like a classical or a literary fiction. So based on the genre of the book, you can put some value here. Okay, and once we have the table or the column inside the table, we can check if the column, so if our command worked or not. So we again do a describe books here, so just to make do a sanity check over all of our commands that, yeah, and we can see indeed there is one genre column available inside this table. Okay, and this example is just to illustrate this drop command here. So right now what this command is doing similarly, that initially we had this table, which is books. Now we'll add one more table inside the database, which has author information. And I'm defining this query as create table authors, where author ID is our primary key. And now we have 3 columns associated with each author, their first name, last name, and birth year. And once I run it, And just to do another check, we do show tables and we can see, okay, there are two tables inside this empty database. We don't have anything right now, just we have created two empty tables with authors and books. Okay, and this command is usually destructive, that it will just get rid of the table. So you just need to be very careful about using drop table commands. But for example, let's say it drops it. So if we said, okay, drop table if it exists, which means that if you find this author table, just drop it from the database. And now just to check if the table is there or not, we run show tables and only the books table is left. We created an authors table, we put it inside the database, then we dropped it, and now we are back to our original condition that there's no author table here. Okay, yeah. So now let's add some data uh, to the books column. So for example, I have there 10 books here with their titles, their author names, in which year they were published, and the genre they belong to. And the command is insert into, which takes this insert into and then the table where you want to put the data. And each and how the values are arranged, that you start with the book ID, which is like the unique ID, and in the order of the column appear. And then you say, okay, once you define that what's the order of your input, you can say insert all these values. And then you have these parentheses like, and then you start putting book ID, book number 1, 1984, George Orwell, 1949, and the genre is dystopian, and so on and so forth for all the 10 books. You have this command, just insert it into the books table, and to check if this data is inside your table, we just do a select command like this select command, and how data filtering is given uh, in the collab notebook we had for last week. Now, once we run this query, you can see, okay, whatever data we wanted to put into the table is here with book title, author name, and genre. As we mentioned, these three columns you want to extract from the books table. Yeah. Next is update. Let's say you have this data inside the table, you want to edit some of it. So now for as an example, instead of saying that, okay, for 1984, we have the genre as dystopian, we want to say it's just like science fiction. We can say update this book table, set wherever you find genre equal to science fiction, and then where title is 1984. So it goes to this books table, finds where the title is 1984, and then set the genre to science fiction. Once you run it, so now you can expect that once we have this select title as book, like the similar command as here. So instead of dystopian, you'll see science fiction here. Yeah. So now this command, the update command, has changed the value from dystopian here uh, to science fiction. Okay. Next is delete, that you can remove one of the entries uh, from your tables. Again, I would say these drop and delete are destructive commands. So just make sure, be careful while using this. So for example, here we want to delete the Great Gatsby book from our catalog. You can just say the query runs like delete from books wherever you find title equal to the Great Gatsby. We ran it. And once we do again same thing, we check our if the command ran correctly or not. So right now we just see 9 books. And the Great Gatsby ordered position number 2 here. In the previous command, once we deleted that, we don't see it here. Yeah, yeah. Next is truncate tables. So truncate is a statement you delete all rows table without logging to delete individual rows, and it's faster because it just says puts them to like null or just deletes the data. You don't have to like individually remove all the entries. So now I'll say just delete everything. Yeah, yeah. So once I run it, it will just say, okay, nothing is there. we have the database, we have the table, but we got rid of all the entries from the table. Okay, so let's go back and insert the data again. Yeah, so now initially we got rid of all the data entries into from the table. Now once we run it again, should be able to see all the entries back. Okay, okay, let's add another table here, which was like the author information about the authors. And yeah, so anything you want to like add to the table, there's like two-step procedure. First, you define the table and the schema for the table, and then you add the data into table. So once we run this query to add information about it, the authors, and when we have this query select everything from books, you can see whatever data we wanted to put in into the authors. For the books we have here, and then for the authors we have like all the 10. So whatever author attributes and features we wanted to add here are available inside the table. Okay, next is that once, let's say you have a database, how do you export the different tables as CSV files? So this is like the reverse of adding CSVs to the database right now. For this database, new DB, I want to extract these two tables as CSV files. Like for example, I want this books table as a CSV file saying books.csv, having all this information, and again authors.csv with all that information. So this is a very nice command that what you say, you can say export database here, and then you have to say the location that, okay, you want to export that database into the same directory you are working in. The format should be CSV and the delimiter should be a comma, like because we have a CSV file. Once we run it, yeah, yeah, and it exported to. So if you go to the Colab and do a refresh, you should be able to see authors.csv and books.csv here. And if you go double click on authors.csv, should be able to see that, okay, whatever data you had is indeed inside the authors.csv file here. And same thing, we can do a check with books, that whatever books we had here, yeah, they are available inside this books.csv file. Yeah, yeah. The last part of today's tutorial is exporting data from CSVs to SQL, and using this command, that's how I was able to make this my database.duckdb, because initially all these files, all the medications, allergies, immunizations, medications, and patient information was into different CSV files. And to just to demonstrate and make a tutorial for these two workshop, I converted them into a DuckDB database. So first, what you do is you have to import pandas to run the CSVs. Yeah, so before we go into exporting, I just would like to mention that DuckDB has this function that you can directly query from CSVs. So let's say you have just like one big CSV you want to query, but you don't want to put into a DuckDB database. You can use directly. There are some functions in DuckDB which you can use to directly query from the CSVs. Okay, let's import globe now. So what globe this package will do is just uh, once we have mentioned that you want to collect all the CSV files inside the directory and put into a list. So once I run it, it will put, since we have books.csv and authors.csv as two files, like what we generated in the previous step, it will say, okay, we have books.csv and authors.csv as two CSV files. Now what we'll do is we'll make a persistent DuckDB database. So initially all our this library example was inside the memory, but now we want to have a file as a DuckDB database. So right now we'll initiate that and say db from CSV, and the command goes like duckdb.connect and library.duckdb. So it will make a DuckDB file. And once I run this file browser, I can see it has created a library.duckdb file here, but it's empty. We don't have any data inside it. So using this for loop, it will read each CSV at once, first put into data frame, then first split the table name. So just get rid of that CSV, just have the name as the table name. And there's like 4 set of commands to put that database. So first you have to register the data frame and say, create this table with this table name if it doesn't exist, and following the same schema as given in the pandas data frame, uh, using this db from csv.sql. So once we have the table schema available, we'll read this df and say insert into table name. So whatever you have from this temp df, so right now the data is sitting into temporary df, and this insert into command will dump that data into the table using the same schema, and then we just say unregistered temp df here. We have it, and since it was in a loop, we have both the CSV file into the database, and then we will close this connection now. So right now, uh, the two CSV files we had are right now sitting into the DuckDB database. But how do I know that they are here? So now we will do the same thing again. We'll make another database. We'll call it libdb, connect it to our library.duckdb, and just say show tables. And we said indeed there are like 2 tables inside, authors and books, and this is different. So it's the same data, but it's a different data set because initially we had this new DB, and right now once from the CSV files we have created uh, a new database with the same data set. So we looked at show tables, which showed us there are authors and books inside it. And once we query the data from these tables, we say it matches our CSV files. Now we are querying libdb right now. All the 10 books are there. If we just want to check things, you can just go to like books.csv, and it should match whatever data was in CSV file is in your DuckDB database. Same thing goes with your authors table here, that whatever you had in your authors.csv, and once you run this, so yeah, once you run this query, select star from authors and libdb, it will show you that okay, you have the same data set available there. Yeah, so that's the end of today's workshop. Thank you very much, everyone. Please let me know if you have any questions.